Amazing. Cool. Close to live. I've had to cancel the past two streams. Okay. Right, welcome to the stream, everyone. How are we doing? So, last stream we were working on getting Magicavoxel imported into the engine. So for those who don't know, Magicavoxel is a lovely little program which allows us to model voxels inside it and even do stuff like animations and stuff like that. So there's this T-Rex here that we can use as a test asset, which comes bundled with Magicavoxel, and it's just got a bunch of keyframes, like so. So we just want to bring this T-Rex into the engine, make it such that we can have animations for voxel models, which will be our test assets for the game while we're prototyping. I don't know what the final graphics are going to be, but voxel graphics are nice and easy to do, nice and easy to make, and we can refine them as much as we want to add the detail that we need to make things distinguishable and animate stuff in a simple way to make it such that things aren't just static and still and look horrible, right? They can at least look somewhat okay with voxel graphics. So we're importing these guys into the engine. Thankfully enough, they have a little custom format called a Vox file, VOX. And we've got a thing called a Vox builder. And we was going to use a single header library for it, but it was in C++. And there was too much C++ isms in there to convert it over to C. And when I looked at it through imhex, which is the hex editor, it had a nice way of decoding the file automatically for me in terms of I could inspect the data in their custom viewer, and it was incredible to help write my own custom parser code, which is like very simple. It's basically just a tree of chunks that you keep on parsing. And yes, we just read in the full file, make sure the magic number is okay. We get the version. I don't really care about the version because it's probably not going to change anyway. And we simply just... Yeah, maybe we should use the version number, but and just stick to one. But anyway, should be fine. And yeah, then we parse the chunk, and it's just a tree of chunks. You keep going down and down and down, and each chunk can have a different grouping of properties. So there's a size chunk, there's a voxels chunk, basically a list of all the voxels, and there's this sort of shape node which helps us get the sort of keyframe information and how many different models there are and how they link up. So here we've basically parsed all of the information and just printed it out inside the terminal. So if I were to say build, right, we don't see it here, but if I were to go to the game, voxel models, T-Rex Vox, let's change it to T-Rex 2. And here you go, you see all this data here on the left-hand side, that's all exported from that Vox file. So we've got the different chunk types, the main chunk, the size chunk, and then the list of voxels for that model. So every time you come across a size, that's basically saying, hey, we've got a new model. And there's 8 models, there's 8 keyframes. And then at the end, it basically tells us here in the shape node, it tells us here there's 8 models, and it tells us that it's a looping animation. And it tells us here as well that there's a bunch of, here are the different keyframes, right? There's the frame index is 2, and the model is 3, right, from that file. It's the it's the 4th model, right? Or something like that. Yeah. So nice and easy. It's pretty cool. So we're going to be taking this. So in this stream, we'll be taking this information and processing it and outputting our own little custom voxel file format, which just handles a model with maybe some extra keyframes and, or sorry, a model that's maybe a single frame or multiple frames of model, right? 3D volumes basically, and outputting that to our own custom format because the Magicavoxel format supports tons of things. It's like a whole scene, and we don't really need that for this prototyping phase. If we might need it later on if we're going to stick with voxels, but we don't need it for now, so we're just not going to bother with it because it just adds far more complication than is worth doing. Be any questions, feel free to ask away. That's the plan for today, and it's going to be awesome. Start off with a quick prayer, but on Friday there'll be a video released on the direction for the game, so keep your eye peeled on that. It's on the YouTube channel, which I'll, I guess, drop down here. There you go. It'll be on there Friday, I think, if everything pans out. So, right, let's quickly pray, then we're going. Father in heaven, we thank you, Lord, for this day. We bless your holy name. Thank you, Lord, for being our great provider. Thank you, Lord, for all that you do in our lives. Thank you for the breath in our lungs. Thank you for the food on our table. Thank you for our family, how they're still alive and well. Thank you for our partners. Thank you for our children. Thank you for the cars on our drives and the relative peace we have in our land. Thank you, Lord God. And Lord, I pray that you help us today achieve what we set out to achieve. Help me make good progress on this voxel model importer so I can move on to the next thing and hopefully get started on the game very soon. Lord, I pray that you help any one of my viewers, Lord, who are struggling with anything in their life. It's some dark times they're going through their life. Lord, I pray you tend to their need. I pray you put that person in their life. I'll help pull them out. I pray, Lord, that you be there with them through those dark times and show them that light at the end of the tunnel. And I just pray that each one of my viewers gets to know you, Lord Jesus, and will accept you as Lord and Savior, and that by your blood their sins are washed clean and forgiven. I pray they understand the gospel and accept you as Lord and Savior before it's too late. Thank you, Lord. In Jesus' name we pray. Amen. Right. Let's go. Now, so effectively we just go over this sort of parse chunk thing, and we just want to like build a bunch of intermediate data, if you will. So I guess we can just have you can call it like a model. Yeah, so you could probably like go over all the voxels and build a yeah, so I think we can. So is the size parameter. It'd be interesting to know. Yeah, to get our own different models and see. Because what happens if you have a model which doesn't fill this whole size, this volume? Uh, Yeah, I think it does that, doesn't it? Because there's this size thing. They're all different. 24, 24, 26. Oh, they're all 24, 24, 24, 26, aren't they? Okay. I guess that works. Right, so you want to basically get the array of models. Um, what else was it as well? There's the yeah, so that will allow us to output maybe. Yeah, I wonder what. Okay, let's just get T-Rex working. We can get something more simple working as well. Um, actually, let's right. So this is the T-Rex one. Let's copy this. Give me a sec. I don't know what's in my notepad. Do screen out? No, I can't do. Can I do secret? Alright, my notepad is safe. Alright, here we go. So that's the T-Rex output. Let's just stick it there in the root. Then we want to also try out a different file from the voxel Magicavoxel thing. Bin Magicavoxel. Come on, VOX. Something simple. There's a 3x3x3. Yeah, what are these? It'd be cool to do something a bit more complicated than just a box, right? There is this little character here. Interesting, at least. Little cars. That's more of a scene. We don't want to support the scenes. But this is interesting, little 3x3. A hole in it. Yeah, we could do this one, or we did the night. You see, I wonder if we can automatically just cut it anyway, because look at this box, man. It's big, right? And maybe we can automatically trim it around here without having to manually do it inside the editor, right? But then if you've got animations, that might be a problem. But we'll see. But yeah, CR night, let's get that one over. Let's have a play with that. So watch the build system go. Here it is. So it's got a shape node as well, you see? That's cool. So by the looks of things, what we can do, so we'll just call this one night. It's got a shape node which tells us there's only one model, and it tells us how to yeah, link all the models up basically into a single animation. That's what I'm looking to say. Yeah, we only support probably one shape node. If there's multiple shape nodes, then I'm gonna let the build the Vox builder error, because I don't think that'll be what we want to do. Okay, so I have this thing called a model which pops up, and I guess there'll be a size. Yeah, see, that's 20 by 21 by 20. It's a bit strange. It can surely be trimmed. Yeah, let's just start off. So we've got HMaths in here. It doesn't matter. DimX. dim Y, dim Z, yeah? Cool. So the other properties that we need is like, hey, here's all of the voxels. So you want, we're only going to be supporting up to a palette of a, what is it? Yeah, there's a voxel exists bit set, and there's a material. There's a voxel exists bit set, and there's a material kind of bit set. So I think, what do we do here? Do we do the bit sets here? So exists. Yeah, then we need to have a swizzled version as well of all that output. So let's just get them working in row major order first. This would be the material. I think it's just called the material. Material words, the material map, right. The exists map and the materials map. Cool. So for so the maximum size is 256 each of them, right? So we can have like a dim max, right? 256 voxels. That's great, because what this allows us to do is basically max allocate these anyway, and then oh no, they don't need to be max allocate, there's a size already. Oh, we don't need that. Cool, this is amazing. So every time we come across a new one of these size ones, we need to make a new model. So we'll literally just have an array of models here. And let's say it's a maximum of 256 models. Let's have a models count. Similar to that, it'd be zeroed anyway. Nice. And right, so every time I come across a new size chunk in the box file, it's starting a new model. So we simply just do an assertion somewhere. Is it like a bounds check one right there? Right, the where is going to be models, I guess. Is that just maybe a string, is it? Yeah. Then the index would be G models count and G for array count G models. Nice and easy. Here's our sort of index. And all we're going to do is simply just get the model. So model M G models. Now just set all the data up. So X nice and easy. Now, the exist map. So we need to allocate these properly, and then they need to be tiled. Or they could just be tiled right away. So effectively, what do I mean by this? So to improve the fact that when we ray trace against, so we have a voxel volume, right? Let's make it 3D box basically, right? And when you're traversing through this 3D box, you have your sort of ray, which comes like through here. Right, if you store your voxels in like a row major order, in memory they will go in this sort of order where they go all the way across the X, and then they might go down here a bit and then up here again and go completely across this row here again, yeah? And they go in that sort of order. But the issue is when you're stepping through an array, it can go across any axis in a 3D in 3D. So what you want, instead of indexing in a row major order, you want it in more of like a Morton curve or Morton order, you might call it. So effectively, it's like a Z pattern. So there's a 3D Z pattern as well. That's what this one is here. So we've got them such that when you, in memory, they're laid out. When you sample from as you're traversing through with array, you're going to get some reuse basically. It won't happen all the time because you have to skip to the next Z effectively and all this, but you'll get a lot of reuse. And it's a bit set as well, so it's proper packed. Like each bit represents if a voxel is there or not, right? So it's super compact. So there'll be a lot of voxels in a single cache line basically, right? There's 64 bytes in a cache line, so it's times 8 of that. So I think that's 512, isn't it? If memory serves. Yeah. So there's 512 voxels in a single cache line. Like just when you're scanning through it, stepping through it when ray tracing. So what's next? Yes, we're trying to find like that code basically. I think it's in shared, but I don't know. That might be the sort of, oh yeah, it's these things here. So voxel exists, load, set, and unset. Yeah. But how are you getting the voxel? Where's the swizzling going on? Block Morton from coordinate. Oh, okay, yeah. So we want this thing. Yeah, so we get the coordinate and we turn that into a, hang on a minute, into an index. Yeah, that's the one we need. Then we need some of the other ones up here as well. Good old Morton. But yeah, so, it's in the engine. We could just include, the header file. Something we could do, although it will include a lot of stuff. Maybe it's fine. Or, let's give it a go. Let's see what happens. Although it will cause the Vox builder to keep rebuilding. Yeah, let's just chuck it in here. So expand. What do I need again? One here is more one. Expand. Don't need the compact. Cool. So we could simply... I think we'll just, just do an X, Y, Z style thing. Should be alright. Yeah, so we want to like copy this a few times. Then with this one. And then we can simply like just do this to X. Cool, next one. Y. And then moving over to here. Z. Yeah. Nice, looking good, nearly there. So we just sort out all these. And this will just be local chord X, local chord Y, local chord Z. Nice. Now I think there is a... X chord Y. I don't know how much of a pain this is going to be, but I'm not sure we're doing too much in this program, so I think it's okay. We don't need a dim Z. Okay, that's good. So, yeah, this Morton Swizzle, it's Morton Swizzled inside of a block, and I forgot how big of the block is. It's an 8 by 8 block. Yeah, so it's swizzled that way around. Is that right? Yeah, maybe that's not even the best. Maybe it could be done better. Hang on a minute. So we've done an 8 by 8. 8 by 8. Obviously is 64, right? That's 2U32 words basically for a bit set. And it's still kind of going to be in row major though. Kind of. It might be good to make like... Oh no, it's 8 by 8 by 8. Yes, it's 3D, isn't it? Run allow calculators. There we go, yes, it's 512. There's 8 by 8 by 8. Yes, so each block is a cache line basically, I think. Yeah. That's amazing. That's great. That's cool. Okay, so that's really good. So when it comes to... We just want code like this basically. and then like doing like a voxel set function. We can get that voxel set here. There's a material store as well, we want that one. So we'll bring these over. Don't think we need many of them. We just need the sets, I think. So load. No load, just those two. Very nice. Cool. Right, so we've got all the little utility functions now. So they will go into here when it's processing all the little XYZs. So we come across size, that means, hey, we've got a new model now. And so it goes ahead and allocates us a new model. Sets up. We need to work out the number of words that need to be allocated. That is stored somewhere in here. It's in one of these functions. This is basically it here. But let's copy these again to make them, put them in here. Right, if we change it in places, it's going to be in two places, but it's fine, right? You'll soon find out something's wrong, put it that way. And I guess we can use U32s. Let's drop it in there. Right, so where's the model? All the U32s here. So that's how many words we need. That right there. Be great. Okay, so we just simply... We don't have the number of voxels. Oh yeah, we do. It's just dim times dim times... Yeah. So alloc array U32. Beautiful. And the other one would be not an exist map, like a little bit set, would be the materials. So it's 2 bits for each voxel. You had to select up to 4 different materials. It's just an index. It's like a material index, right? There's 4 different options per voxel. Sorry, per voxel model. So you can change our palette, basically. So, yep. What's next? We allocate those. So you come across a size chunk first, then you come across a XYZI chunk, which basically means here's the voxels. But for some reason they don't store them all in a they don't store the empty space in like a compressed thing at all. They just store a U32 for each voxel, and that packs in a byte for X, a byte for Y, a byte for Z, and a material index. So these are them here. So we've got this here now, which allows us to do X, Y, Z, and then the model, so we get the model at the back. So it's model dim X, model dim Y. Then we do model exist map. Yep, start index is 0 and voxel index is this. Beautiful. Cool. So that'll set all of those in there in the exist map, but there is also a material storm. The material store needs to store in some material index. So that should just be I. And we shouldn't be allowed, though, to come across. So if you come across a voxel which is greater than 4, greater than or equal to 4, it doesn't fit down into 2 bits. So that is a big problem. There is an piece of exit code, I think. Exit help. No, exit error, that's the one I want. To do an exit error, we can say like, vox file found material index greater than 3, I guess. Do that, greater than 3 in vox file. I'm wondering if we can, excuse me. This should really contain, yeah, we'll get the vox file in here. So char star vox file. Quite dumb to keep putting that in there. Right. Failed to read vox file. Nice, so now that's globally accessible, which makes this a lot easier. So we just do a new line, then we just print out like, hey, file, printf. Well, I guess we just do this, right? File, vox file, path, s, new line, g, vox file path, yeah, nice. We're gonna have to repeat that absolutely everywhere. So in these errors, found material index this, but it is greater than 3. Cool. Nice. Then we pack those two things into there, and amazing. Some materials. There we go. So that should be grabbing absolutely all the models and their voxels and putting them into a properly Morton packed block of voxels, right, swizzled the way the GPU code expects it already. So that's in memory right now. And the final thing we need to know is how to sort of like how many models there are. And so, there's this T-Rex, right? And it's got these animations. And I'm only going to do what per file. There's only allowed to be one model with one animation, I think. Because I don't know if it supports anything else other than. Yeah, so I think we can just do. If we did that, then we can there's literally a folder structure here, so you can view all the animations and that and just quickly switch between them and view them. So that should be cool. And so you can put stuff in folders and that and it'll work. Then, yeah, so we come across multiple of these, it's a problem. but we need this to be able to know how to export it. So there'll be a models count, I guess, and this models count must be equal to the amount of models in the if models count is greater than or is not equal to g models count, then we have a problem, I think. So exit error. Right, so we only expected a single. Yeah, so let's try that car one out. Because that's going to do multiple of those shape nodes, right? Think. Can I see that? There's a cars one here, yeah? So we grab those cars, bring them over. Because we're not supporting this like a scene. We're not doing that. Because it's just easier to only import a certain subset of the format, right? So we've got the one for the night. It's very simple. It just defines one model. So a size shows up in this XYZ, which contains all the voxel data. Then a shape node, which tells us there's only one model here. And then would just display keyframe information if it had any, but it doesn't. But the T-Rex does multiple models, then comes up with this shape node and defines all the keyframe information. Yeah. So we'll support these two. But this one here with the car scene. Material index 253. Oh, they've got like this stupidly big palette, haven't they? Great. Right, we can just ignore that for now. So where do we do that? Let's do this. Cool. So I think it might be munged together though. So let's just quickly change the cars to cars 2. Right, so here's the cars 2. So you've got a size here of 15, 34, 13 symbolizing a new model. Then you've got all the voxels for it. Then you've got another size with a new model. And then it has a shape node, which says one model, then another shape node, yeah? So clearly, that shape node defines like a model and all its frames, yeah? Cool. So yeah, I guess we can call that really a frame, right? I think we can call this like a model frame. Yeah, I think that's wise. I want to call that a frame. That would be a better name. Oh, very cool. So yeah, but they call it models though in their own file. But it's like a frame, right? Um, yeah, it's bizarre. Yeah, but then they call them frame index for like a model ID anyway. How many models inside of a shape? They call it like a shape node or whatever, but cool. So we'll just call ours a frame, even though it's a bit inconsistent with the Vox file, that's fine. So with a frame, then you want to know how many, if you've already, I guess, have a Boolean, found shape node. Maybe you don't need that. There's already, right, we're getting closer. This is good. So if models count is greater than, sorry, not equal to G frames count, then what we need to say is we exit with an error and we say that the voxel, so found multiple models inside a single Vox file. Well, we don't support that. The multiple Vox inside a single Vox file are not supported. Something like that. Nice. So you go over all the models in here, which we call frames, and we can now link them up. So the ID is just an index. Yeah. Cool. So you want to know as well what the frame index will be. There's no way to define like a length of the animation, unfortunately. That's not defined within this format, which kind of sucks. But it tells you if it loops or not. So you have a frame index, and we want to know if it loops. Right, so attributes loop. So that'll just be G loop. Cool. So go over all the models, get the model ID, get the frame index, possibly. So that'll simply just go G frames. Model ID is super weird, but there we go. Frame index, frame index. Ta-da. Cool. So that's like on a timeline, what frame index is it? Nice. So I think that's all the data extracted now into memory from the file that we need. So what we're looking at achieving now, so this T-Rex for a minute, let's look at this T-Rex again. Right, so unfortunately that palette, oh, there's a note section. All right. Anyway, yeah, we can shuffle those around and sort that out. Get them imported properly. But yeah, let's bring those back. Yes, that's them all in memory now. So the final thing we need to do is get this into a custom format, although I do have a bit of a question actually. Yeah, so it seems like these dims and stuff is kind of wasteful, right? It's saying 24, 24, 26, when if you look at the actual model, it is not that, right? There's a lot of empty, yeah, 24, 24, 26. It's empty space all over the place. Can you change that? Can I reduce the, I think it's 24.6 on the Z, which is above. So I think we can, oh, so red, green. Yeah, it's just green. It's this one here, Y, yeah. So we reduce that. Can I reduce that to say 20? That did it, yeah? So if I go back, huh, right, so it's 20 again. Can I save that? You know what, it shouldn't be editing this one anyway. Can I open up a different one? Do, 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 do. How does one open assets T-Rex? Here we go, this is our guy. But oh, this is where the shader thing is. Cool. I didn't realize. I saw them in the file, but I didn't realize they're there. You can generate stuff. Cool, that's awesome. Anyways. Why is this not in the right place? I need to figure out how to get this project to be in the right place. There's patterns. Oh, so you can do like different brushes. That's cool. Yeah, it's pretty dope. Right. Where? New project. There's a button there. What? So a project is in a folder? So I'm wondering if you basically have to use their folder structure. Open that folder. Right, Magicavoxel. Folder project. Yeah, it's Magicavoxel Vox. Custom directories, subfolders, place within access selectable categories, backup. Changing project path. Open the config file root. Okay. Right, I see. There. You have to get in there and... You see, I wonder if we could... There might be a licensing problem, but just bundle it in the repo basically, but... Anyways... Yeah, there might be a licensing problem if I did that, so just avoid it for now. But yeah, there's basically a config, and you open up this guy. There's a project directory thing. Oh. The model. Right, so we can do the full C drive path, maybe. This kind of sucks. Like, it would be cool if, you could just open up a file explorer and open up a different directory in the UI, but, it's workable. Can't complain too much if the rest of the program's fine. Right, what about that? Alright, we're here. Sweet. Here it is, voxel models. Ta-da! T-Rex 2. Here it is. So what I was trying to picture, right, is this is so much waste of space, right? And you don't want the person to come in here. But I'm wondering, like, we could probably automatically just detect the empty space in the exporter and just shrink it automatically, right? And then provide some offset so that it's in the right place, like a local space offset in the ray tracer. And then that way, they don't have to manually do this and get it snug, right? They can be an artist and do whatever they want inside a volume, and then it automatically sorts it out, kind of, as long as they're in the same position, right? So, it grows vertically, doesn't it, as well? Yeah. All right. So we went that down to about 18 or something. Then, like, I don't know, you save it. Unrecorded. What does that even mean? Hey, Deros. Yeah, make it. I've done a voxel ray tracer already. Um, yeah, because it was just easier to do. Um, but in the future, if I wanted to stick with voxels and I wanted to do some kind of animation, which was not which was not frames, or I do like bending and stuff, then it would have to turn into meshes. But yeah, for now, I just did the ray tracer approach because it was kind of easier, and it's just compute only that way for now. Well, sorry, it's not compute because I do use a. But yeah, I'm not making a bunch of different meshes other than a box, basically. The box is procedural as well. But yeah, so it's cool. It has its problems. The ray tracer, you've got to optimize it still. Like, it's not too good at the moment if there's a bunch of empty space. That would be a real performance problem. I'd have to, you're better off like eliminate empty space like this, or have it being able to skip multiple voxels, right? But in like a kind of a map level thing, which I don't have yet. Yeah, I'm just trying to eliminate the empty space right now procedurally. So I'm just seeing if the models can be different sizes on the keyframes. So how do you save, Magicavoxel save frame? Let's save it as a model though. Right, there's this tab key. Uh, no. I've shrunk it. I'm just trying to get it to save. Save animation. Can't be. Oh, there's a save button right there, right? That work? Unrecorded frame. Hasn't been saved into your timeline, lost you to version limitations. Frame-based animation was added as a legacy feature, but is frequently unavailable in later updates. What? Hang on. What's this trying to tell me? Usually refers to a frame that has been saved to your timeline or has been lost due to version limitations. Was added as a legacy feature, but frequently unavailable in later updates. It needs to struggle with animation because frame by frame animation was removed in versions. Ah? It was removed? But like, here it is right here. Oh, hang on. Oh, it worked. Right, you just press the plus button. Cool. So it wasn't removed. Because I swear I swear I downloaded the latest version. Maybe they didn't. Eh. Right, I don't think that was correct information. But anyway, we found out how to do it now. Press the plus button. Ta-da! So yeah, it turns out you can get different sized volumes in the keyframes, right? This is useful to know. So it means we can probably ignore. Yeah, so we can say everything is centered around the middle of the floor, basically, right? And we've probably got to switch the X Z around. Sorry, the Y Z around because their coordinate system is, as I would say, incorrect. So you have to switch this around. So that'll be Z Y. Hang on a minute. Yeah, so Z Y. Beautiful. Cool. Amazing. So these dims maybe mean nothing. So what this means then is, I think what we're better off doing is scan over all these, work out the bounding box. Yeah, compute the bounding box. Yeah, the problem is though, yeah, so if we increase these, it will grow. I see. So they're probably got to be even numbers as well. Yeah, so maybe that should be a thing. Dims should be even numbers. And that'll then mean that we could say that the origin is somewhere down here on the floor. Maybe. And then, yeah, the origin is on the floor. And the box could be relative from there, maybe. Yeah, but what happens when you change this y-axis then? Or can you change that in the config? Probably not. Oh, you can. Oh, is it y up? Is it actually y up? No, that's not y up, is it? Axis. It's line. Fix it. Because I changed that and it changes RGB. Yes, you got to change that the other way around. But anyway, so save as, close it. So XYZ. Well, I'm glad they can change that. So I don't have to change these then. That's cool. Then I don't have to completely change my brain while I'm using Magicavoxel. I do though, right? What does that even mean? Object. Oh, I see. These are exporters, aren't they? Damn it. That's what IO means, is export. That's not fun. Magicavoxel change. Alright, I don't think you change it. That's fine. It's okay. Anyways. So the other thing I wanted to look at is... Yeah, so... If we shrink the Y, which is here then... That literally brings it down. So it builds off the floor, right? So we should then respect in that regard as well. So the sort of bottom middle is the sort of origin, if you will. Right, let me just make the most sense. So if we go over all the voxel models, we can deduce this sort of bounding box, right? The sort of min and max of the frame. So we could work out a min max, and then from that we can deduce. So the frame, maybe we can just ignore this. Do you want to have probably a, I guess XYZ and then EXYZ, you can get a dim. So you could in theory ignore these ones. I think we could ignore these. And instead, bring this in. You read the number of voxels. I reckon you can then back up the cursor. I think it's just G cursor basically, so you point a and we'll restore it back. So equals start cursor. So we'll do a for loop, read it once. It's not the best code, but it works. So read it once and figure out, because otherwise we'll just have to copy it into some other place anyway. So I think it's actually quite probably the best way to do it. So move the cursor back, decode X, Y, Z, and simply just work out some kind of bound. So where's this frame thing? So this would be like frame end, whatever this is. Yep, that's good. Okay, so the frames get allocated here. So allocate a new frame. Then work out for me the min max. So we actually want to store in here. End is going to be equal to 0 automatically. So x is equal to u32 max. We just do a min max type of thing. So y equals min. Have I got a min? This will do. So we're trying to work out the minimum between these two. So y and z. Then we want to do a max. So that'll just be sort of... Yeah, I wonder if there could be better names. So you could say min x. Probably max x might be a better name. Because we could say up to and including. And then simply here we shall do a max. Max, which is obviously a max, yeah? Lovely. So we scan over all of that and just get them in max. Then it's simply a max take min plus 1. And that gets you the dims, right? If they're the same, then it's a 0 dimensions, right? Sorry, if they're the same, then it's a 1, right? There we go. Now, what else are we trying to do now? So you print out the dims here, store them inside the frame. Now we get the actual voxels count. So this would be like the we can probably call this the frame voxels count. potentially. That does need to be stored inside the frame itself, though, so that's probably what we're looking for there. Inside the frame, looking for a voxels count as well. Very, very nice. Cool, very, very close here. So allocate ourselves the bit sets, store the voxels in the exist map and the materials map. So 2 bits per voxel for the materials, support up to 4 different materials. And so we just scan over, do the Morton block swizzle thing. You get the voxel index inside there and store it using these macros into the bit sets. And there we go. So that should be the better way of doing it, because now what you have is a sort of, even if we become very lazy and yeah, so see here they can be different sizes and it still doesn't matter, right? Because, or they can waste a whole bunch of space, still doesn't matter. Because our code is going to now know the min max range of voxels and the bounding volume is going to be nice and snug around it. So that'll be very helpful. That's very, very cool. So when it comes to, yeah, that's it. That is it. Cool. So we've got everything ready, right? We've got this frame with all the data we need. And we've got whether or not it loops and how many frames it has. That's all the information that we need to export. And then we can load it up inside the graphics code. And it's warm today. Yeah, so the thing we've got to double check then is that min and max is correct. So I've just got to figure out like, so if we're basing it around this sort of origin position here, yeah, that means local space. What is it that we do? So that means every time we position something in the world inside the game, it has to be from the bottom middle. And then that way we can say, when we have the scale and the dimensions of the object, then yeah, it's just you push the y. Yeah, so the scale is 1 or something, it'll be a full length of y going up, but then a half along the x and the z, basically. Yeah. And that'll all be done in the racing code. So all we have to do, we don't actually need to output a min and max. That min and max is purely actually for the, just to calculate the dims properly. But yeah, we'll leave it in that structure anyway, just in case. I don't think we need to worry about it. Right, so now this leaves us to, how do we save that to disk, right? What format we're going to use? Good question. Well, we got the encoder stuff, right? So we would just use that. So it's a little custom encoding system. And we just want to do a little binary file So I think we can just... It can go straight to... Some of it can go... Yeah, no. This is going to be easy. It's going to be fine. So, right, go code, modules. We could probably stick it in Vulkan for now. Just stick it in here, maybe. Stick it in Vulkan for now. New file. We'll call it voxel. What'd you call it? We can't call it vox because that's what input data is, right? So it's kind of like an animation, right? It's like it's one animation. Let's call it a voxel model. It is just a voxel model, and it has as many frames as it needs. Yeah, actually, just double checking that. So does it support up to 30? No, it supports up to many frames. Yeah, that Google AI thing was completely wrong. Seems like it supports tons of frames. That's cool. Can I just keep adding frames? Oh, can it ever tell me the maximum number of frames? Yeah, that might be useful. What was it called again? It was the imhex. Wow, this is stupidly big. What happened here? What made you decide you're huge? Where's the DPI? Scaling. Oh no. It's Diddy. Alright, we got it. Same times. Still 1.5. Right, looks horrible, but it's better. Yeah, the native one looked way better, but there we go. Right, so where's the patterns? Because last time this was actually helpful. Am I using a different version of imhex or something? No, anyway. Last time it showed up, but let's go to the patterns. Load pattern. Yeah, I'm looking for a Vox file. You showed up last time. Ah, you know what? I just realized I downloaded a new version of imhex and I have one on my system already. The past one I installed, this one here is newer and is a portable version. That would make sense. Here's the better version. Yeah, this one's way better. Right, so we're going into assets. Right, what was we coming in here for? Ta-da! And it found it. Beautiful. So I was looking to see if they had... Yeah, this is it. Because they have this timeline thing, right? And so... Is there like... Is this stored somewhere like a maximum sort of thing to play to? Because when you play it, I think it does... And then it loops back around, you see? And I remember looking at the data. Do 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 do. Shape node, it just tells you it loops. Tells you the frame, the individual frames that they're placed on, but I don't think it tells you where. Right, so let's go for the chunks. Do 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 do. Frame ID 0, that's not it. We ignored that one. And there's the 8 models. So I wonder if it's... Alright, that sucks. There's the layers, which basically have nothing. I wonder, is a transform. The group node. Is it like a 30 somewhere? But then that'll not easy to find. Can we look for a 30? The 30 would be, so 16 is 32, isn't it? So it'd be like a, no, sorry, F. Yeah, so 10 would be 32. There'll be, confused now, just, so it'd be 30. I'm looking for an X1E. Nice. Is that right? So yeah, that's right. Because it'd be 16 then. Cool, got it. Right, so there it is. But I think it's going to be more as a string, actually. Because... Oh, anim range. That looks like our thing. See that? Anim range. Where are you, please? You're in the metadata right at the start? Where's that? You got the Vox, the magic, the main chunk, meta. Oh. Meta. No, it's after that. What's the next one? Size. Oh, it is in meta. Right at the end. Oh, does this one not parse it? Oh, this one doesn't know how to parse it. Unknown data. But if we read it, it's like there's a bunch of zeros for some reason, and then you've got this sort of range and in range. Man, this is crazy. But okay, so this is great because at least it can tell us. It's just how do we get it? If not, you got to put like a special frame in there and we got to use that. But yeah, something to get at as well, like the frames count, and you probably want like a frame max, if you will. So frame max, I guess, would be so we could put a breakpoint in, but then we don't know how to put. There's the extended one, which is the one which supports the, this is the meta chunk. It's not even in there. The problem is not documented. Let's see if the AI knows. Long shot. Meta chunk. This thing, let's give that a go. There's an underscore in there as well. Right, where did it get this from? As global metadata dictionary, its purpose is to store scene-wide parameters, most notably the anim range property, which saved into meta chunk. So it's documented here as a change, but as a serialized dictionary. Yeah, but you're saying that's a string? Right, let's put this dictionary thing in there. That's a DI. See, so where's the meta? Yeah, so I think that might be, it must be a dictionary then. If so, we've already got the code to parse that anyway. So literally, if we just did this and then change that to meta, can I reload the thing? And what do you know? Dun, 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 dun. It works. Amazing. So it's just a dictionary. And value 0 to 30. Amazing. So we can get that out. So we need another chunk called meta. Right, let's get that number. So the number is a U32 is this one. Right, so where's the... So we want like a frame min and frame max. Frame min, frame max. Lovely. Huh? Don't have any, sorry. Okay, so the meta, it's got that dictionary thing. So this is how we parse dictionaries at the moment. They're just a bunch of key value pairs, basically. So we just read how many there are. And we pick out on the ones that we know which are in there. So there is, we'll debug log them so we can always pick them up, but we'll find the ones that we specifically know. And it's called anim range. If anim range exists, then the value actually stores two numbers in there. So we need to do this thing, right? So you do a string, so be a G frame min, and then we need an end pointer. Yeah, end pointer. And then we know there's gonna be another one in there as well. So we just go from the end pointer all the way to the end, and that'll be max, I think. We'll see how that goes. So here we'll just output frame min and frame max. All right, that's super cool. Happy with that. Let's double check to make sure we've got that parsing up. So we need to actually remove or comment out these ones because these are going to assert otherwise. Because files we're trying to use are not technically supported. Can we run that? What happens? Do 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 do. Crap. We'll bring that back in just a tad. And chunk size 0. What do you even mean? Do, 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 do. Main meta chunk size. Yeah, there is anim range. You see it there? Min max. Perfect. Okay, that's parsing. But overflow when reading input file. Bum, bum, bum. That's not very nice. Oh, it's saying build error and then it's pointing to, oh, right. There's multiple things running at the same time. Right, overflowed when reading input. I see. What causes it to overflow then? Do we read over the full chunk? I think we did. We can get that in the debug quick. Alright, what are you complaining about exactly? So an overflow in it. Yeah, cool. Great. So we can just get in here. So I wonder if it's to do with the meta. If not, it might be to do with moving the cursor back, but I don't think it is. So this should have been 27 bytes, basically. So what was G cursor? Where's G at? So G cursor here is 32. So we go down. So we did 59 take 32, 27. Yes, that skipped perfectly fine. How many chunks is it going past before it fails? Right, why are you pausing children? Chunk. Obviously, that's main. Yeah, that's invalid there. That children's size is invalid. Right, so I think that must come from meta then. Right, what's going on there? Okay, what makes that invalid? Size. Oh, it doesn't read the size anymore. That's probably why. Yeah, I took out the stuff which read the size. As we do this manually when parsing voxels. There you go. Cool. Anyway, so let's check those. Which ones are erroring now? All right, let's take a look at this. Frames count is 9, is it? Interesting. What makes you say it's 9? So 1, 2. Right, okay, so maybe you can end up parsing. Yeah, so maybe there could be extra frames. Alright, well, we can handle that. That's an easy one. There's extra frames in there which are not actually used in the shape node. I don't know what I did to the model to make that happen, but they're there, put it that way. Maybe not then. Maybe not. We'll check that. So, right, 1, 2, 3, 4, 5, 6, 7, 8, 9. There was a 9. Okay. Interesting. Fair play. So there's redundant data in there, which kind of sucks. All right, though. So in this case, so we don't actually export all the frames. That's a big no-no. Right, so maybe you want to call them models. Go back to calling them models, and then the frame is actually going to be something else. Frame is going to have a model index and a yeah, and we just write out the ones which we need in line, something like that. So go back to calling these models. A frame will just be a model index and a frame index. And we'll join them all up into a single structure when we write out to the file. So you'll have a frames, you'll have a models. So these would just be models. Um, cool. So we kind of want to know if you come across multiple of these shape nodes. So we'd probably just say Boolean. You know, has found shape node. So if G has found shape node, then error, G has found shape node equal true here. Let me just say exit error. And this error can just be that one down here. We falsely identified it. Cool. So we go over all the models. So that would be G dot frames count should now be set to models count. There we go. Go over all the models. read the model ID. So it's frames, model ID, frame index, and then we do a model index. Oh, yeah, it's just a little remap, little, I guess, a link. If you're just thinking in like terms of a database, a link table, I guess, maybe. Anyway, it's horrible, but there we go. Right, so that's all the data. In memory, we can now just output it to a custom file. So let's go to our little encoder file. Right, so it's just a little custom encoding format that I've got. So effectively, we want to do something like this. So what we're targeting files, and it's going to be binary and some magic number. Let's do this. So string to hex. We want to do it in reverse. So we want to just call it, I guess, voxel model or yeah, vmod, I guess, for voxel model. So it'll be DOMV. And that's all we want to do, is that's the little magic number. So vmod, there we go. Lovely. So that'll be the magic number for the file. And this is the root. It supports like variable arrays and all that stuff. So we're going to have a frame as well. So voxel model frame. I think we only need dims. So we can do, well, yes, we can have them all packed and all this. Yeah, it's just the thing. What do you want to do? I want to store. So we just store the dimensions. That might be enough, and they could probably fit into a byte each. I'm just considering though. We'll probably manually pack these on the GPU anyway, and that'll be a different structure. So yeah, I think we'll just do this for now. So it'll be dims. And then there's a bunch of U32s. Where are they stored? Yeah, so this is voxels, the number of voxels. But that's just dims. You know, like a inner product, whatever you call it. So we could already work that out anyway from that data. And you could already work out the number of these voxels, this words anyway. You don't need those to be stored in, those we worked out at runtime basically. So they don't need to be stored in the file. So we could, no, they need to be stored in the file if we want to do the variable length array things. Yeah, let's store them in there for safety as well, I think. Oh, where's that file gone? Right, so we want to say voxel, so it exists bit set exists map words count, and you also have material. And then you just have the exists map. That's just gonna be a variable length array. And that'll just work. So these will be, the way the encoder system works is these basically just get replaced for a single U32, like a relative offset from these positions in the file. And there's code generated code, which basically does all that for you. And when you use the binary writers and all of this, it does it all for you basically. So that's super cool. And all we just need is a variable length array of frames and stuff. So you just say frames count. I think we need like a, do we loop basically a boolean whether or not we loop some kind of like frame min and frame max. I think that was it. Voxel model frame. And I think that's all we want. So if we change the file, right, we have to up the version. So we'll put it in like a dev mode and you say like, I forgot what you do now. There's a special keyword. There's upgrade, and this means you have to write upgrade code, which is horrible. But there's a way to basically get, like, just blow away the history and just up the version number internally. And that gives you the freedom to change the file, and the build system won't complain, basically. Right. And only when you take away the dev mode does it increment it. Sorry, does it set it in stone? Yeah. So, yeah, we blow it all away. Yeah, we won't. So these will just be certain assets that'll be written out by the build system, and only it cares and the game cares what the version is, right? But we don't care about history and upgrading, because every time you change it, you just rebuild every asset again, right? No big problem there. So I think this will be the file format that we want. So just got to code gen it now. So the way they typically work is there becomes a header file that gets generated inside the cache directory in the build folder. And we should just be able to do this, although, so yeah, it says Vox model. Yeah, it's already done apparently. Oh. Apparently it's ready. It's all here, ready to go. Yeah, so see the byte offsets, yeah. I mean, maybe it's a byte offset anyway. Yeah, that's done. Yeah, there's a header in here where it's just got all this stuff. It's got like a checksum if we want to do checksums to make sure the integrity is fine. It's got offsets and stuff. Yeah, it's from the current position, so it's a relative offset. Yeah. And 0 obviously means null. But yes, we have ways of doing this stuff, and we have ways of verifying the binary to make sure it's fine. And we have type info if we want that too. But yeah, we need to do like this binary writer and all that, but this is gonna be awesome. Right, so we get to write out that code now. So after we parse all the chunks, we effectively want to start a new binary writer. I have not used it for a while, so maybe there's something. I don't know if I've used it yet. Completely fine though. Although I don't think the Yeah, there's some things to sort out, but it's fine. Anyway, so we do the new binary array. Maybe we can take this one. The issue is this Vox builder. I've been using it without any of the code base at the moment, but I think now we've got to basically use some of the engine code. So I might have to get rid of some of this now because it's going to be double duplicate. Yeah, it's redefined. Let's just write the code because that's going to be the most fun thing. So after we've parsed everything, we this binary writer, and this will. Yes, we want to start encoding something. So I think we just do start. Do we see this like in the documentation or something? No. All right. So it will be voxel model. We start with that. I just call it W. I love me a W. And this should be an end. Is it V0? Yeah, V0 voxel model, so version 0. And we take the address. Cool. Right, so in here we effectively just keep writing stuff in. So this will get us a voxel model. And so now we can just keep writing all the stuff in here. So we can then say, write out whether or not we loop. We can write out minimax frame and all that. We still got to save it to disk at some point too. Got to figure that one out. So the next one is we want to store the. See, I'm hoping this does the. Yeah, start will set the metadata all up and the header, so we don't have to worry about that. So there'll be a sort of a V0 voxel model. There'll be a way to alloc the variable length array. So we can do a frames alloc VLA. We put the M in there, pass in the binary writer. This will then bump allocate after the file. So the binary writer will start on this voxel model, right? So it just bump allocates the header of the file, which is the encoder header and obviously this structure itself, like the rest of it. So it just bump allocates this, like that header and all this stuff. And then whenever we do this allocate a variable length array, we're just saying, hey, bump allocate more data. And because we're using this function, what it's going to automatically do for us is store in, it's going to automatically update the count and the byte offset fields, I think. Yeah. You see here, automatically sets the count and it updates the byte offset to be the right thing. So we don't have to worry about doing that ourselves. So we just say, hey, G frames count. There we go. Then we simply just get a lovely little pointer to the V0 voxel model frame. We can call it F here. And all we do now is loop over all of the frames. So this, we want to get two things, right? We want to get the voxel model. So I guess I'll call that M. So that'll be part of the address of G models, then G frames, index, model index. Yeah. Right, here we go. Then we want to get the, sorry, that's frames. F will be address of frames index. Very good. There's the model M. Lovely. Now we just fill in F. So F dims is equal to model. Yeah, I feel like we're going to have to make it just use some of the engine types now because I've brought them in here. That's a U8 times 3. Right, whilst we've got a couple of VLAs basically. So, well, what does my encoder system support? I forgot. Is it just VLAs? Can it do? It can do arrays, obviously. Can it do? It could do pointers. Like, it could do pointers. I don't think it can do infinitely long arrays. Well, not infinite, but without count specified. Because that means we could say, I know what it is, don't worry about it. That would be interesting, but I guess it's safe. More safe if we have it. That special keyword's safe, you know. Yeah, just allocate more VLAs basically. So you do your, U32 star exists map. So it'll be V0 voxel model frame, exists map VLA alloc, frame, the writer, and the count. So these were worked out here. We could rework those out. Nice. Then rather than exist map, it'd be the material map. So now we simply just copy all those words over. I can just do a core copy element many, exist map, and the exist map in there. That's all of the voxels swizzled in a nice 8x8, 8x8x8 blocks. They're all Morton swizzled in the 8x8 by 8. Let's exist words count, and there we go. So that should be writing all the data. I think that's everything. Yep, let's just double check. Do 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 do. Yeah, we didn't need a number of voxels in the end, I don't think. Because you can get that from just doing like a product of all of those, right? And max. Looking good. So all we need to do now is simply throw the whole file out to disk and done. So the beautiful thing is we already have a OS file writes all. I don't know if that's got a boolean on there. I think it does. Yes, it does. So you can just do one of these and you can just complain if it doesn't write out. argv2 So it's argv2 and we're trying to output the data. So because it's a binary writer, right? It literally just writes, it's bump allocated the whole file in memory. Ta-da! So we literally just like throw it out to disk by just going to the allocator, the start right there, and you just do the size. Now I think there's some shortcuts to this, like binary writer size or something like that. So you can just do it this way and it automatically just does the, yeah. So you write it all to disk and it's just as simple as that. Now, well, mm, 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 yeah, so when you do a start, doesn't that always just, it fills in the header, it will allocate, it won't necessarily be clear. I think that's interesting. It won't necessarily be clear. Yeah, so I think more realistically, what you want to be doing in that size is actually be doing not necessarily the start. That's what you want. Cool. So then what's the point of capacity then? Yeah, it's a little bit. I think we want another one where we say, because your end is going to put null in there. Okay, that's fine. Yeah, so the end is going to. Oh, when does it get set this special value? Right, so you can serialize structures and stuff. Hmm. Has not been finalized. Interesting. I'm not sure that's going to impact us right now, so I think it'll be fine. That's just problems when we use it in the future. But yeah, basically, it's going to write out the file size in there and the checksum. Oh yeah. That's what you do. You don't use that. You use, hey, I'm writing out M and M file size, right? Because that's gonna, yeah, M header file size. Yeah, because it's got a whole bunch of stuff in there. It's got the file size, the version, the size of the header. It's got the checksum, and it's got some hashes in there and stuff to. Yeah, it's kind of a bit big, but it's not massive. And the idea is your files are going to be big enough, so you don't really care. Cool. So the file size. There we go. If that fails, then it's a problem. Cool. So that should basically be it. That's all the kind of code to get it output. Let's check the build system. So the build system, when we run this sort of Vox builder, we're outputting text files apparently. No, we're not. So we'll call it vmod voxel model files. That's what we'll call it. We'll get rid of those as well at some point. Get rid of those now. There used to be a text file. We won't be supporting that very soon. So all we've got to do now is solve the fact that we're trying to include engine code now into this Vox builder. I was trying to compile it without the engine code, but now it's going to use engine code. We'll just sort that out quick. Oh, hey, the Galactic Past. Past, welcome. Yeah. Yeah, start streaming back in February again. That's right. How have you been? Right, I'll be right back. Welcome back. I forgot I ain't got the Twitch chat on there anymore. I was recording video and stuff. That's why. Okay, so anyway, where was we? So yeah, engine code has now been included. That's included encoded.h and then included core. So realistically, we need those. Yeah, there's a few things we need to do, but so the build system needs to. Where is it at? Build main. That needs to now do this sort of like core.o stuff and all that, you know, their object files and things, and we have this way of doing it. And now Where is it at? Box builder, where you gone, my friend? Here you are. So yeah, you need your own list of, I guess you'll call them inputs. You probably just need these ones. Yeah, but core needs OS, I think it does as well, doesn't it? It's one of those things. Yeah, so I think you just get all those. Where's the .os? Hang on a minute. Right, there we go, looking good. So we've got a link exe thing, that's what we want. Where you going, my friend? Here it is. So that's good. Oh, I need to also compile voxbuilder.c now as well. As a separate .o file. And that'll be in the cache directory now. Yeah, so do we care about... We care about the code gen being done because this depends on the code gen. We need to have these silly code gen dependencies, implicit dependencies passed in. Okay, that ought to be good enough, I think. Yeah. Right. So that'll be nice. So in the Vox builder, now we've got to get rid of some stuff. Basically, platform doesn't need to exist anymore. I was thinking about not using the engine at all, but we're using it now. Because so I copied and pasted a whole bunch of stuff in here that we kind of already have. And it also means that we could probably just have a little custom allocator, or what do we say, a little global allocator. We could just leave this in here. But we might as well just use the whole engine, right? Let's get rid of these. More and expand, we might as well just include. Where are these declared? Graphics. Yeah, what about this one? It's an internal at the moment. Yeah, we'll leave these ones in here, I think. That'll be fine. Alright, here we go. Cool, so we'll need like a little, so the encoder code gen, it does some sort of like global allocator like this. And it just used malloc. So it really wasn't that much better. But yeah, so now we've got this whole allocator interface. We can just pass it into everything that needs it. Yeah, but yeah, so if anything that we got which passes into engine code, we've got the allocator which just uses that simple alloc function, which is backed off a virtual alloc. So this assert bounds things. I think it's like debug bounds basically. Oh, array bounds. Cool. And I think we want this for the frame down here actually, thinking about it. Cool. Right, what else is the problem in this code base now? So this actually needs an allocator. He's passing allocator. There we go. And supposedly that's all okay now. So we just hit run and see what happens. Right, duplicate symbol. Read all and write all, but that's not necessarily true. Oh no, it might be because no, because the engine does have its right, it's just Windows. Oh, Vox Builder still oh no it doesn't. So it seems like it's not trying to recompile Vox Builder.o for some reason. I don't know why that is. Let's check why. It's right there. Oh, Voxel Builder. Whoopsie. Game crash handler needs to be declared. Get that. Codegen.c. There's some crash handlers and stuff. Which is great because I guess you get the stack traces then. I don't know if you need game exit. Is that even a thing these days? It is, okay. Just dump them in here at the bottom. I guess we'll get B stack trace as well. Nice. Right, that's great. So it looks like what it's doing is it's building it, the C file. It does take a bit, but it's fine. And then it builds the exe. So yeah, it's actually 500 milliseconds to build that. It's okay. 300 milliseconds, by the way, is Windows H. Include Windows H. Why do we include Windows H? Oh, because we do virtual unlock. I've got an OS API for that now. Virtual memory reserve and commit. Oh, we can't do the fixed thing anymore. But that should be fine. I did it so we could preserve the memory addresses. It's fine. So read, write, and then what was the other one? Address out. Okay. Right, let's go with that. So we try that. Right now that builds in a fraction of the time. Well, it's half as quick. I don't know why. Yeah, I could have swore I tested 300 milliseconds on a compiler Windows to H, but maybe that's other things. Anyway, it made it better. Right, so why is this complaining? Why are you complaining? So we want exit error. You want to help me out? Our page size. Yes, what you need to do is you need to actually initialize the system, unfortunately. So OS pre-init, I think. And you might need to initialize the log system. Ugh. But this would obviously impact, you know, startup times for these applications. And maybe we could find ways to reduce that. Right. Do we need the logging? Right, is that really a thing we need? The pre-init just basically gets the page size into a global. Hang on a minute. It's crashed again. Did a log, didn't it? Wait, it's an infinite. Let's look at it, you know. Right, handler. Oh, sorry, that was the TLS as well, wasn't it? Alright, let's just initialize it all. Nice. Cool. Right, that's nearly done now. So that's using the engine code now, which is super great. The only issue we have is that we have to change the voxel models to use a reduced color palette. So we can change this one just to be one of 4 colors, I think. Maybe we can increase it, I don't know, but these indices are a bit off. But yeah, we just got to look at every color that's been used and make sure it uses at most 4 different colors. We could extend it to support more, up to 16 maybe. Maybe that's what we should do. Do 4 bits instead of 2. And then that gets you 16, right? That might be better. But yeah, then we can try out these, not cars. Cars shouldn't work. We should delete cars. But we should, because cars has 2 models. Not supporting that. But this one, this is crazy, right? So many. Oh, one is all the way down here. That's not very nice. Alright, it's lower left. Fair enough. Cool. So we just got to basically, edit these models, or maybe even not use their models, just do our own ones. And then get the loading code. Yeah, let's just do our own simple models. We'll just do very, very simple ones. Do our own loading code. You get those building. They'll be building here. And then we can turn off the logging information now, basically. Doesn't need to log anything anymore. Oh, spot define wrong there. Yeah. So we should make our own little models. One with animation, one with no animation, basically. And do the loading code in graphics VK, which will load the new voxel model files, just these things, load them straight into GPU. Well, it's got to upload them to GPU memory right away, basically. And then, yeah, that should be all right, I think. There might be some other things we can do to this file format, but I think this is fine. But yeah, so upload them to GPU, make sure the offset works properly where it's aligned to the bottom middle of the volume. And then everything should just work fine, which would be cool. And we should be able to save it and it will hot reload it into the game, basically. That's what we want to achieve. Awesome. Right. So next stream will be Thursday, 7:30 p.m. GMT +1. There is a schedule down below on Twitch if you want to check that out. Yeah, thank you for everyone who's supporting the channel. Appreciate you all. Thank you for coming by. There's a way to get access to the code to run on your own local machine at on a GitLab. If you follow the Ko-Fi link, you can read the information there, and it's £5 a month, and you get access to run the code to run on your own local machine. The code will not be up. This specific code won't be up until it's done, so hopefully next stream, the Thursday, hopefully it'll be checked in. It's going to break the code base, so don't check in stuff that breaks the code base. What else? On Friday, there's going to be a video on the YouTube channel that will come out, which will be that one, which will be a presentation. I've got it all recorded. I've edited basically 2/3 of it. 1/3 needs to be edited still. And it'll be uploaded in just basically a sort of a pitch, if you will, of the game that we'll be working on over the next sort of the prototype for the next sort of 6 months, I imagine. So we're just finishing up the engine where it has support for these voxel models which come from Magicavoxel, and we can use that to sort of make a prototype graphics and build a prototype, and from there we can go and see what we want to do. But yeah, all the plans will be coming out on Friday. You can catch those on the YouTube channel. Yeah, any questions, come by the Discord anytime. But yeah, I hope you guys have a good Wednesday. Hopefully see you Thursdays, a stream on Fridays as well, and a stream obviously on Sundays. Check the Twitch schedule down below for more information there. Right, God bless you all. Hope you have a good rest of your week if I don't see you. And I'll see you very soon. Bye bye.